All right, part H, our last set of notes for part 2, vertex form. So vertex form, also known as completed square form, super handy because vertex form gives us the vertex. So let's look at Desmos again. I'm going to make a new graph. So this one we looked at, it says y equals a x minus h squared plus k. I'm going to add all parameters. And notice my vertex here currently is 1, 1. My h value is 1, my k value is 1. Changing the a, not changing the vertex. So let's go in and put in a point, hk. Let's change around h and k. And notice my vertex is staying the same. Furthermore, notice k moves my graph up and down, and h moves my graph left and right. As h gets more negative, I move more to the left, but notice the minus sign in here. Again, negative, negative, it's actually going to say x plus 5.6 squared. Something to watch out for. So moving it around, we get this. Notice if I changed this to be x plus, it's not the same anymore. Then I would need to have the x coordinate be the negative h value. Yeah, so this sign here is a little bit tricky. Don't let it fool you. So vertex form, very nice. The y-intercept, though, is not as straightforward in vertex form. So let's make this -2. Let's make our h value something like 3. And our a value, let's go with 2. Let's go with something, actually, let's go with a half so that we can see. I can see that my y-intercept is 2.5. So to figure out my y-intercept of 2.5, I have to plug in x equals 0. When x equals 0, I'm going to have my a value times 0 plus h. That's just going to be h. Actually, let's put this back into normal form. And then down here we would have hk. All right. So I plug in my 0. 0 minus h is negative h, but negative h squared is positive h, and then plus k. So it seems to me that my y-intercept is when I plug in 0, and then I multiply, and I would have h times a times h squared, and then times k. And let's see if that gives us our point. That does not give us our point. Why not? Oh, let's move that off. All right. So where is my point? Why is it not here? Let's think about this. H squared is 9. K is -2. Oh, something is wrong. Oh, plus k. That's what's wrong. I shouldn't be multiplying by k. I should be adding k. When I plug in 0, let's change that to a plus, and there we go. All right, so now as we change things, that makes a lot more sense. Okay, so we get our, now we have to get our y-intercept by plugging in 0 for the x. This is a shortcut to remember it, but really it's plugging in the 0 for x. So let's go and look at a problem. So actually, let's sum this up here on our notes also. Wow, that's not very straight. Here is going to be hk. Over here is going to be when we plug in 0. So that would be 0 and f of 0. Our x-axis intercepts, this is what's really nice about vertex form, is that if I want to find the roots, those are when not x equals 0, but of course when y equals 0. So if I think about a, x minus h squared plus k equal to 0, this is back to our first method of solving a quadratic. I can subtract k to the other side. I can divide by a. And then I'm back to this just square root both sides. Again, when we square root, we're going to get two answers. So x minus h plus minus square root negative k over a. Obviously, one of those is going to have to be negative so that we end up with a positive in here, or we have no solutions like this case. In this case, our k is positive and our a is positive. We would square root a negative and get no solutions. Square root of negative k over a. And there's my two solutions. It's what's so nice about vertex form, because we easily can get all of our important features